So rigging in Houdini today, it's not what we're known for. So that's a nice way of putting it. And currently everything lives in the object space, which means it's not procedural at all. So it's one of the least procedural parts of Houdini, if not the most non-procedural part. So what we decided to do is actually move it away from the object level and into geometry level. So we're moving rigging from the object level, object context into SOPs, which is amazing because now if you want to say mirror a skeleton or add a chain or add a constraint, you can do it more through nodes and you don't have to really script anything with Python or there's not, it's much better. And I'll show you why. Rigging in Houdini now, people have shipped games with it. They've shipped the movies with it. But realistically, it was kind of time for a reboot. So I'm really happy that we managed to get everybody on board and pull the trigger on a really drastic change for one of the kind of core parts of Houdini. So an overview of KineFX. So it is based in SOPs, like I mentioned. The primary focus is for kind of data processing, so dense data processing. So you can think of mocap for this. And the thought here is that Houdini is great at data processing. Be geometry, volumes, images, and animation should not be any different, and skeletal meshes should not be any different. So it is kind of our DNA to kind of chew through data, and I think mocap is where that lines up the most logically first step for us. It is very much inspired by a state machine. So this is a little bit specific for games, but if you know what a state machine is or have used one in the past, this should feel right at home, which is weird for a DCC to go down this path, but it lends itself very much for the way Houdini works with nodes, and you chain nodes together and you override poses and you add dynamic parts to it. It is very much lends itself to work like a state machine. And this is the first update, right? So this is a longer road here. We are going to get all the way to where an animator can sit in Houdini and work. But right now, that's not where we are. Right now, we're in the foundational kind of framework level where a tech animator should be able to sit and comfortably do everything that they need to do. For future releases, we'll get closer and closer to that artist-friendly workflow. But for the time being, we're still very much on a tech animator space. So let's see what this actually looks like in action. So this, I have a pretty classic scene. You can see there's only 1, 2, 3, 4, 5, 6, 7, 8 nodes. Very basic. We're loading in an animation through FBX. And then our first thing is we're going to do an offset on the leg. So you can see the animation is still flowing through, but I can just modify the rotations of that joint. And if you want to kind of hide or change the visualization so it looks a little bit more like your traditional bones, you can with the fins. And now we still have all of SOPs available to us. So here we're just isolating the feet. We have some handy terrain, and we're going to raycast those feet against that terrain. And it's kind of hard to see here, but it is actually kind of doing what you want it to do. And then we can feed those new feet positions into an IK solver. And that will give you kind of what you expect, which is the original motion with an offset intercepted plus IKs on the feet. And because this is Houdini and everything is live and everything is always cooking, this is very much non-destructive. So you can change the terrain, the feet will adapt for the terrain. And you can also add different offsets in different areas. Animation still works. Everything works as you would expect. And it's worth mentioning that the bones are just pieces of geometry. So the bones themselves are points, and then the connection or the hierarchy is displayed with curves. And then if we want, we can kind of drop this rig pose node wherever we want to add more offsets. So in here, if you want to, after it's been raycasted against the terrain, you want to add a little bit of an offset, and maybe you want to actually animate that offset. So you want to set a key here and over there, you can. So the currency that passes up between all of the nodes is just points, just like any other SOP. And any animated data or animated parameter lives on the nodes themselves. So here is where that animation curve is going to live. It's essentially baked down to the skeleton the moment it comes out of it. But if you need to go in, you still have those two keyframes exactly where you left them, even though you ran through an IK or you ran through more stuff. Wherever you have your sparse data, you maintain your sparse data, and then the dense data is just kind of implied as the next node that you're coming in is going to have dense data baked into it. So I mentioned that this is a curve and this is a regular piece of geometry. So I want to prove that a little bit further by showing you this is our humble curve SOP, which is due for some love. And here I'm using the rig pose because by default, the regular curve SOP or any SOP can't really deform a curve as if it was a skeleton. And like I mentioned before, we can also change the look of that curve to make it feel a little more bony. So it's when we started doing it, it was a little bit of a mind blowingness to be able to kind of just work with curves, and it felt good to have these little fins drawn, but it's entirely a preference that you can or disable or enable once you get used to things. And yeah, so it's just basically it's geometry, and the currency is you have a P attribute for your position and you have a 3x3 matrix for your transform. Transforms are stored in world space, but you can convert them to local space, do things to it, convert the matrix to Eulers, convert them back, move them to quaternions, whatever you want to do. Again, it's just data that Houdini can sling around without any problems. Then we get into an actual character. So this is us bringing in this character done by the great Christoph Dessy. And here you see that there's three kind of chains of data flowing. So the first one is skinned mesh. The middle one is a bind pose skeleton or a rest skeleton. And then the third one is the animated skeleton. So here you can see I am just adding some keys and I'm just going to move the arm up and down really basically in FK just to show again that you can animate a character and you can kind of visualize what the skeleton is doing with the bone deform. So that's what actually calculates the skinning. And then if you want to export this out to FBX, it's just a ROP as you would. So this will export out skinned skeletal meshes. And we can just save that out and you'll see I'll bring it into FBX review and it's doing what you expect and we can export that out. So even this, for people familiar with animation in Houdini, is magical because getting a skeleton to kind of round trip, add animation to it, export with the same hierarchy, were all pretty hard things to do before KineFX. And now it is pretty much what you kind of expect and hoped it would be. Hopefully you're happy and hopefully we hit the mark, but at least it's what I would expect from Houdini handling these things. So again, we have these three data flows that we can intercept any of them. And now I'm gonna kind of show you how we can intercept or create new ones of each of them. So we'll start with the first one, which is the skin mesh. So one of the kind of top features, or one of the first features that even if you don't care about mocap, you don't care about animation, a lot of people will use is poly reduction on skin characters. So here we have a character from Paragon from Epic, and I did a little bit of already cleanup here. You can see I did a blast to remove all the LODs. I did a conversion from poly soup back to polygons. I don't think that's necessary anymore. And then some UVs, but I want to also apply an animation to it. So now what we're seeing is I can poly reduce a rigged character with animation playing through it completely non-destructively and see the updates. So I can basically play back the animation. I can detach the animation at any point. You don't have to kind of save it or dump it to disk and then reapply it. And you can kind of just be aggressive. You can see here there's a little bit of a stray vert. And at that point, you can either just kind of go in and smooth that out, or you can just say, okay, let me play back. Maybe that was a little bit too aggressive. That's where things started falling apart. Maybe that's as far as I can push my LODs. Again, just this is our bread and butter of Houdini. So we have the original, and we can kind of start decimating by halves in each of these. And then by the time we get to the last one, it is a complete new mesh. So LODs 1, 2, and 3 were done with just the poly reduce and nothing else. And then LOD 4 actually it's a voxelized mesh. So you can see all of the kind of machinery becomes one big bloop. And then the UVs and the skinning are just attribute transferred over. So there's no extra magic here. Polyreduce will interpolate the skinning properly. And if you want to do things with attribute transfer, you can as well. And we can see this is not baked at all. I can just swap out the animation, see a different animation, and all of the LODs, see it. And you can also see that I'm playing 5 Foley characters with high quality lighting and everything at around the 20 FPS. If I go to wireframe, it goes up to 24. And yeah, so we're very, very mindful of performance and wanting to make sure that it's a smooth experience as much as we can. So now we'll get into building a skeleton. So this is your bread and butter joint creation tool. It's our skeleton node, and it has a lot of different awesome snapping capabilities. So the regular point snapping works, but we also have snapping based on the view camera. So it basically finds the center of the geometry automatically. You can tweak it. You can tweak it with child compensation. And you can kind of just go in and start placing all the bones that you want. You can add more bones, you can reparent them, all very interactive in the viewport. And yeah, so it becomes pretty easy to go in. If you want to change the orientations of a bone, you can just simply go in and grab the bone and rotate it. Or you can use predetermined kind of orient operations, and maybe you just need to fix the up factor a little bit if it didn't give you what you wanted. So here we'll just kind of continue building through. Again, pretty easy to go in, and even if it doesn't give you what you want exactly, you can just go in and quickly just kind of change some things around. And you can also, if you press P, that will give you a parameter for the state, which you can go in and actually zero out joints. So in this case, I wanted things to be exactly on 0. So I can just simply go in, hit P, and get the actual positions of each of the bones. So here I can just go in, play with it a little bit. I'm pretty happy with how that side works. So now I can mirror the skeleton. So it's something that I mentioned earlier, that if you're doing this in object space, now you're in Python land writing how to duplicate nodes. But because this is geometry, we can very easily just mirror it out. But you'll notice that my skeleton is not, or my model is not symmetrical. So I can drop another skeleton node that can operate and modify an existing skeleton as an input. So you can either pass the skeleton without any inputs, or you can pass it an input and the skeleton node would actually go in and modify it. So in this case, I'm modifying the duplicated skeleton, so basically the other half, and I can quickly just place everything where it needs to do. So you can see pretty quickly I put a bunch of joints down on this relatively complicated character with multiple limbs. Then we need to bind it. So this is one of the fun parts for Houdini. So of course, I'm going to show you the long way of doing it. You can basically build an HDA, which I have for my case, but you need to drop a bone capture lines, which basically add some resamples the curves or the skeleton. Then we need to drop a tet embed, which generates a tetrahedral mesh from your original mesh, which is going to go into the biharmonic capture node. So here you can see we're just generating the tets, and this I didn't speed it up. So this is as fast as it goes. There's no shenanigans here. And again, if you have this as an HTA, it's just a single node. But it's 3 nodes, bone capture lines, tet embed or tet conform, and then biharmonic capture. And now I can basically feed this into a bone deform and do my usual rig pose trick, so we can start looking at the skinning. So you can see now we have, and I have to change the display flag. So I looked at the actual deformed one. I can see that it actually does a pretty good job with capturing. And this is going to move some joints in the background. Then I can kind of play around and find the joint I actually do want. And we'll get into custom controllers in a little bit, so to kind of mitigate some of this. But here I'm moving the arm, and you can see, yeah, it's good, but it's a little too soft. So I want to kind of separate some of that out a little bit. So let's get into painting weights and kind of actual skinning next. So to paint weights, the way I like doing it is basically I use my rig pose node and I actually set some keyframes. So I actually have a little nonsense range of motion fake animation on it. So ideally you can actually use the full mocap, which is what I do on characters. But on this character, I just manually move the arm up and down. I drop a capture layer paint SOP, which is the same mold that we had. And I just set a couple of things. So you can actually change the preference. So middle mouse becomes the region selector. So you can basically middle mouse around and select the different bones. And then you can just basically start painting as you would. You can see I can quickly paint areas that I don't want. I can switch from paint to reduce. All with just right-click menu in the viewport. Can change the visualization to be infrared just to make sure everything is actually there, and sometimes the black values are hard to see. Then you're basically doing bread and butter stuff, and the nice thing here again is that there's animation and you don't really need to bake it out or write out the skinning to disk or anything. It's just you can just disconnect that rig pose or just delete the keys out of it. So here again, just start moving down the joint chain, and you can middle mouse to select the different joints. So here I'm going to actually be painting across 2 different joints. So I can draw one, middle mouse click, select the other one, start filling it out. You can really easily just see the volume. And then we can actually start smoothing, which is something that in other softwares it would be heresy because you would get weird skin data across everywhere. So it is worth also mentioning that we do have pruning and regular procedural ways of altering the skinning data. It's just an array attribute, so you can kind of do whatever you want. You can do attribute promote to detail to get the max value and then flood them back down, and it's really powerful to do things like robots and mechanical rigging. But for your traditional painting of weights is also really, really powerful and really, really fast. And then next we'll get into kind of the whole band playing together. So I actually made some mistakes when I rigged this. So I actually needed to add some more joints. When I started wanting to paint weights on the claw, I realized I just didn't have enough joints there. I have it forking, but I don't have it actually where I need it to be. I kind of have it at the end. So I just go in and I quickly add some more points on both sides of my skeleton. So I did one side, then I'm going to go in and just quickly add some more bones. Getting it so just the view is perfect. And you can see by just clicking on the other joint, it reparents it. And it just feels nice. It just feels like what you would expect if you were with one bone selected and the other one. Now it basically ran the tetrahedralization, the biharmonic capture, and the capture layer paint. So none of this work that I did before, even though it was a different skeleton, it didn't really go away, because the capture layer applies itself back based on the name of that region. So it worked out pretty well. So you can see there, it's still clean. There's nothing weird about it. But now I want to kind of start skinning this claw that I set up. So I do my usual trick of doing my fake range of motion. But I'm noticing that it's not really rotating from where I need it to rotate. So I'm going to drop an additional skeleton SOP because I don't want to keep redoing the skinning every single time. The skinning is okay and I'm going to be overriding it, but I do care about where it's going to be animated. So I can just change the bind pose kind of while I'm painting weights and animating. So this is pretty incredible workflow, and it feels amazing because you can... I usually struggle with finding the perfect place to place a joint, especially on hands. It's kind of tricky to make sure that the hand will be able to make a fist if you're rigging an open hand. So usually you have to just deform it and kind of see it. And a lot of the back and forth is a pain that you kind of have to apply the animation. It does break it down. Maybe you have layers. But here you can basically see what the joint placement is how it's gonna affect the animation. You can see, okay, that was probably a little too low. So let's move it up a little bit. Yeah, that feels a little bit better. So let's leave it probably a little bit closer to that. And as you're kind of finding where the pivots are for that animation, you can always kind of come back in and paint. So again, this is something that used to take me probably hours to kind of sit and go back and forth. And honestly, something that some riggers really like, because there's a zenness to it where you just kind of sit and you're kind of combing grass and kind of arranging sand. But in a lot of cases, it is kind of, you just need to get the job done and move on. So this makes that task a lot easier. So again, you can come in and just smooth some stuff out without fear that you're going to be setting some influences somewhere in a corner. And you can kind of just go in and you get the idea. So again, incredibly powerful, super useful, and I can't wait for you guys to play with it. And you can see I have a little bit of a straight weight over there that I can kind of just go in really quickly, go to reduce, kill that, and be happy. So now you've seen how we can create skeletons. You see how we can modify the skinning, we can modify the geometry, and you can modify the animations. But let's see how I actually do rigging in the traditional rigging sense. So the constraints and the expressions are kind of handled by our VOP network. So it's basically a rig VOP, which is very similar to a point VOP, but it kind of has some setup to calculate some stuff for you, so you don't have to worry about it. And then we also have a couple of SOPs, or one or a few, basically related to the full body IK. So you have the actual full body IK solver, and then you got a couple of configured nodes to set up some actual constraints and weights of the solver. All right, so now let's take a look at how to actually set up this constraint setup. So in this example, I'm just going to start again with the simple curve. I'm going to add 3 points, and this is going to be a leg. And first thing we need to do is add a rig doctor node, and this just initialize the names, attributes, and the transforms for me, so the IK solver can actually set everything up. I'm also going to do an add SOP with delete geometry but keep the points option, and these are going to be my control points. And I'm going to feed both of those into a rig attribute VOP. And here we actually have a really cool feature where you can just click and drag from the viewport into the VOP area. And here I'm just going to take all of my points. So it's going to be 3 controllers and then 3 driving or things that are going to be driven. And then I'm going to feed those results into the output. So basically I have my 3 bones, my 3 controllers, and then the 3 outputs. And here you can see if I move my controllers around, I can basically solve that curve in an IK solver fashion. Again, no magic here, it's just regular geometry that you're moving around, but it is just, instead of an extrude, the operation that you're doing on the curve is a 2-bone IK setup. So again, just like you saw in the very beginning, you can make this procedural, you can have this go up and down based on a sine wave, you can have it collide against the terrain. It's up to you really how to skin it, and you can actually add offsets to it. You can do all sorts of fun stuff. You can turn this into an HDA as well. So if you just want all of that to kind of sit into a custom rig, that is also possible. But this is kind of the lowest level, how to do that setup. And then just to drive that point a little bit further, because people are like, no, really, can you do this with like an L system? Again, here's that same setup. So we're going to use the rig doctor to just initialize some stuff. Now we're going to use the blast this time because I don't want every single point as the control. I just want to say these are the things that I want to drive, and these are going to be the target. And we're going to use, instead of the rig attribute VOP, we're going to use the full body IK SOP, which is even a little bit easier to set up. So we can basically say, here's my controllers, and here's the thing that is going to be driven. Instead of mapping based on an attribute or based on a mapping index, we want to map it based on just a name. And you can see here, all I have to do next is spin the root of the full body IK. And I'm applying the full body IK solver to something that is not human at all. So this is just an L system tree. So it works with quadrupeds. It works with any kind of chain. This is pretty powerful. Again, if you need to animate some trees, or if you need to animate anything really, even like pieces of destruction or rebar being bent, the full body IK solver will work for it. And you can kind of build these little constraint setups pretty easily. But who wants to rig trees, right? So let's look at, again, that character, this time with some textures. And here, again, exactly same setup that we did for the tree. I'm going to select some of the targets that I want to be. So it's going to be the hands, the head, the pelvis, and the 2 feet. I'm going to blast those, basically everything else away. And then that's going to go into full body IK. And that's going to go into my bone deform. And then again, we just have that rig pose to add some offsets. And you can see now we have a basic rig, so you can start posing your characters. So here again, very basic rig, but it's something that you can start playing with. And you can see the feet are a little bit sliding there, so I actually want to do a couple of things. So first, I want to parent my hands and head to my pelvis. So again, I can drop that same skeleton node that you saw it, and to do that same operation. So now when we move the pelvis, or when we animate the pelvis, the hands and the head will move with it. So that's kind of mini rig number 1. And then we can actually start playing with the full body IK a little bit to just give us some better results. So we can add some configuration to where we can say the feet have a little bit more priority than the rest. So we do want to kind of keep the feet a little bit stronger. And we also want to kill the dampening a little bit. So it's making the whole body a little bit too stiff. So it's kind of moving, progressing the weight of the feet all the way to my pelvis, where I actually want that knee to bend a little bit. So again, here, super basic. Even if you know anything about rigging, you can see with like 3 nodes, we have something that you can actually start posing a character and start, actually, if you wanted to animate this, you could. Animators are going to want something different, but proves the point that it is pretty trivial to kind of start setting these things up. And we'll start ratcheting up the level of complexity, right? So in this case, we have the same character being the driver of the full body IK. So we just kind of made a little sibling rig that we generated on the fly. But what we want to do next is actually transfer motion from a different skeleton onto this. And it's the same setup. So I'll share that here. So here I have another animation clip, just a range of motion that I captured. And here what we're going to do is go through the whole process of retargeting live. So the first thing we're going to do is the rig match pose. Basically just make sure that both skeletons have the same pose. So basically if you have one in an A pose and the other one in a T pose, it puts them both in the same space and kind of calculates offsets based on that. So here we can kind of pull the scale a little bit down just to make sure that the hips are the same. Next thing we want to do is the map points. And this is you're basically in the viewport clicking and dragging to determine the relationship between the bones. So you say left bone now becomes left foot. Spine 1 becomes spine 2 becomes spine 3, so on and so forth. I'm going to let this play, but you can see how quick it is to do this. Once you do it, you can either export the mappings out. So usually you have a mocap to game mapping. Then you do that setup once and then you can reapply it. Or you can use our preset system to also reapply that. So that works just as well. And I'm not going to do the hands and the fingers right now, even though I could, but just for times, I'm going to skip through that. And first, I actually want to do an FK transfer. So we could do a full body, but we also have this other mode, which is you're just transferring the kind of local rotations across. And this works really well for some cases. So in some cases, the full body IK works better. In some cases, the FK transfer works better. It really depends on the animation and the use case. So both are available. At any point, you can modify that pose a little bit. So here, I'm going to have to enable the target so I can actually change it. And I can kind of just fiddle with that a little bit. You can see maybe the arms are going a little bit too much through the body, so I want to fix that. Then we can kind of, as the animation is being retargeted, we can actually move the arm out a little bit just because we weren't too happy with the solve. Sometimes the clavicle or the hands give us trouble, so we can fix that. We can also drop a full body IK, then use that instead of the FK transfer, and see the result that that gives us. And this is, again, the faults. And you can see full body IK just solves things a little bit better. And that's usually the preferred way that I choose to retarget. You can see here that at this point, you have a retargeting system set up for you that works pretty well. At any point, you can just delete that old part of it, just clean up the network a little bit. And then here, I'm going to add some offset. So here, it's not the best to add an offset before you do the rig match pose, because that is going to calculate some offsets based on it. But if you do, down here, it will do what you expect. So you can basically change the incoming animation before it goes into the full body IK, or you can change the result after it runs through the full body IK. So at any point, if the arms are going through places, or you need to kind of move the feet a little bit or adjust anything, you have full agency of where everything is going. And once you set this setup once, which again, 3 nodes, you can basically swap out this animation import with different files on disk and retarget a whole lot of them. And luckily for us, we have just the thing in PDG. So PDG, again, 2 nodes. We can use the file pattern node or file pattern top to find all of the different FBX on a disk or on a directory. And here you can see that by clicking on the work item, that actually enables that work item and sets up the scene to be able to visualize. So we can quickly just spot check all of our animations and see if they're being retargeted properly. We can visualize the original one and the retarget. And when we're happy, we can just say, all right, let's do this. Manual will process, in my case, 16 in the same at the same time, parallel. And if you have a farm, you can actually throw this on a farm and do 1,000. So I think we did the whole Carnegie Mellon data set, which is around over 1,000 in about an hour on a local machine. So if you do have a large data set that you're kind of scared of retargeting because it's going to take time, this should help you a lot, and this should help make your life a little bit easier, so you're not scared of retargeting at all at the animation set. You can do it, see what it results, and then do it again, and not be super scared of doing that operation. This would be a little bit of a dance break. So this is some awesome retargets that our developer Mikna did, and it's just showing a bunch of different Mixamo and Paragon characters being retargeted to motion, and just to show again how varied the characters can be. And I'm going to get into this guy a little bit more next, but you can see how it's a really robust system, and really this is the kind of the key offering that we have. It is our retargeting system. We're really proud. We worked a lot on it, and it works really, really well. So I'll keep things moving along. You get the idea. So let's talk about this Iggy character a little bit more. So again, this is one of Paragon's characters that Epic has put up. And I'm just the cool thing here is that it is 2 separate characters that are just one large skeleton. So when I saw it and we were looking at the characters to retarget, I was like, this looks kind of like a Halloween costume. So it looks like those riders where the lower body is the creature and then the upper body is the rider. So I wanted to retarget human emotion to him, ideally mocap. So that was the kind of crazy thought of kind of live mocapping onto this character. So we tried it and it works pretty well. So here we have the original source data being retargeted to a minimized skeleton. It is still the same bones from the full skeleton, but just so we can visualize it and we can solve the full body IK a little bit easier, we kind of isolated the kind of hierarchy that would make a human hierarchy or close to a human hierarchy from it. And then we just apply those motions back onto the full skeleton. So you see a few things fall apart. The head kind of wobbles a lot, and then the feet are just kind of going through the character. He's just kind of dangling there, his little legs. And ideally we do some stuff with like an IK chain to kind of pin the feet sideways and do some stabilization on both the tail and the head, so it looks a little bit more lively. So that's what I have to show you here. And this is actually a lot of information at the same time, but we have some integrations with Unreal and some mocap suits. So I'm going to be talking more in depth on those here coming up, but I just want to show this. We have, I'm wearing a mocap suit that is going into the Axis Neuron, which is Perception Neuron's software for capturing or for translating the mocap data. That goes into Houdini, which does the translation between the human to the character. And then that is using the Unreal Live link to actually stream straight into it. And if you notice the legs of the rider, they are being constrained to the deformed version of the creature. And we're also kind of offsetting the rider a little bit up and stabilizing the head and the tail. So you can see here, we're seeing a little bit of the head stabilization, and I can just act out, and you can see my upper body is being transferred to the rider. His legs are just pinned to the creature, and my legs are being passed over as well. So let's talk a little bit about these integrations, because this is a really cool feature. This is actually part of Labs, so we're going to be releasing those nodes through Labs, and the Unreal Live link is going to be its own plugin. So it's going to be its own project, much like the Niagara plugin, and it has its own repository. So the two suits that we've partnered up with is the Perception Neuron Studio with the Unreal Live link and how it is to set it up. So this HIVE talk also doubles as documentation because I'm leaving and there's only so much time on a day. So here we're going to go straight into the live link and how it is to set it up. So here on the Houdini side, it's basically a node, and you funnel that into whatever you want to send to Unreal, and you hit Start Server. This actually starts a web server that then the Houdini live link will connect to. At that time, you will have a Houdini subject available to you. So if you change in your skeletal mesh, so it's the link preview and it's using the right character, now data should be being sent back and forth. So now we can either have mocaps running through it, but in this case, I just wanted to show it the most basic, which is I'm just going to throw again my rig pose, and I'm going to move the arm around, and here you can see just how fast it is. So basically, Unreal is currently pinging that web server for information, and as you're updating your pose, that streams across and it works. So even if you want to see full materials, you can set that all up in Houdini, or you can just use it, the live link, and kind of see the full character in all its glory. So now let's take a look at this retargeting for this character. So this character is a little more complicated. So it's Crunch. And you can see here, it actually does some really nice stuff. I'm going to break it down here in a second. And again, the live link is still working back there. So as I'm visualizing a full animation, I can still have that kind of feedback happening on a separate screen or on a separate monitor. And the cool thing here is that I'm actually doing both tricks. So the upper body is using an FK transfer, and the lower body is using a full body IK. And then we have some other of those rig attribute FOPs for all the little pistons on this character. So all of those you can see are being resolved properly. I'm going to show what happens when that's off. And you can see this is pretty interactive frame rates for both sides. So if we go here and we disable the pistons, you should see that those don't update anymore and they're kind of sticking out from the side. If we turn them on, it will be fixed themselves. So even this network is live and things are updating as we move across it. So here again, rig match pose, map points, configure full body IK, which is one node that I didn't touch, but basically does the same weighting that you could do on the full body IK node itself. We have an FK transfer and a full body transfer. And then this rig pose is actually, its job is to kill the hand. So you can see my fingers are actually not working here. And that is because I actually need to kill the motion of my wrist on this particular character. And here we can see if we disable the blend, it kind of works. So this is just what the full body IK is doing. So you can see the hand is pretty bad. Again, we need that rig pose. And just the upper body doesn't solve that as well. It's kind of a complicated character with a lot of joints. So the full body IK struggles a little bit. So in this case, the FK transfer is actually the best way of doing the upper body just because of the way the character is set up. And the lower body is using the regular full body solve. So here again, we can see the pistons. Those are just being updated right after. So again, if you used a state machine before, this is your bread and butter, right? So you have two animations coming in. We used to call this sausaging back when we were working on production, to where basically lower body is doing one thing, upper body is doing another thing. And then you're playing some actual procedural setup. In this case, it's baked, but theoretically you could be doing this at runtime. And then I'm just adding a rig pose and just hand animating so we can visualize what those beautiful pistons are doing. So if we turn that off, you can see that the bases don't update. And if we update those, they all work. And these are just basic game constraints. You basically just say one joint, look at another joint, and that's all it takes to set these up. But again, pretty fast, pretty reactive. And next we're going to look at how to set up the axis neuron setup. So here I have a similar animation. The thing that we have to go into the axis neuron is to actually go to our settings. So here if we go to settings, there's actually, you can broadcast the capturing or you can broadcast the editing. So in this case, I'm broadcasting the editing. Make a note of which port you're broadcasting out of. And you're just going to drop a neuron node. And then you set the IP to the one you want. You say connected. And then you just funnel that in as you would. So now the animation is kind of streaming in live. So if I scrub on my neuron or if I'm having live capture, you can see that's coming through, passing through Houdini, and you can see Unreal in the background, still hooked up, still doing stuff. So even if I change my network, you can see that everything still continues to flow through. And now instead of a range of motion, I'm doing this awesome kicking sequence. And again, you can see what's happening on the actual character. And you can do this live, which is what I'll show you here in a second. But I just wanted to show you what the setup looked like. So again, very, very simple. You just have to, and you can change an animation on the neuron side as well. And you can see it changes it on the Unreal. So theoretically, you can even have Houdini running in the background and not open at all. And just everything is running. And you're only dealing with the neuron and the Unreal, or you can have Houdini open and playing with that as well. And again, this is just showing, this was actually when I captured the motion that I just demoed, but instead of broadcasting the edit, I'm broadcasting the live. So here you can see the perception neuron has great fingers that mapped properly and kind of come across. And as you're doing these motions, you can notice that I can be a little more careful with my emotions, and I can take a look and see when things are going to be crashing into each other or where I need to add a little bit of an offset to my motion to make sure that things are going to look right on the character. And it feels cool. It feels like you're actually the character, and you feel like you're strong, and actually you can bring more into your performance by actually seeing what the final character is going to look like. You can see here everything is still working. We still have the pistons all firing, everything streaming, pretty great frame rates, no struggle on any side, and kind of running across multiple software. And then here's the Rococo setup. So for this one, we go into the Studio Live. In this case, we're going through custom and just making sure we're on JSON version 3 and UDP. By the time this is released, hopefully we'll have a Houdini icon in there, and you'll just be able to set that up. And then again, very similarly, you just hit connect and everything will kind of come through. So in this case, we have this stake with 3 different characters. And again, very similar setup to what we had with the other setup. And in this case, we actually do support props and multiple characters. So here it just comes through and you have an actor name point attribute that you can do to set things up. And this is just getting the data, but you can kind of go a little bit more crazier and actually set up full characters with deformation and actually have the 3 characters coming through and playing the setup at the same time. You can see here we start to take a little bit of a hit, but it's up to you to kind of determine what quality you want and what kind of data you might want to see. Here's another setup where we have a camera also being tracked and kind of coming across. I just copied 2 points, a pig head to it. So we can see we just got a big blob of characters and the cameras, and then you can basically do whatever you want. So in our case, we're just doing some blasts to isolate it, which is actually the reason why the other scene is a little slow. Blasts are slow. So now that I think about it, you probably just want to do a group or on the full body. And yeah, so that's the Rococo integration coming through with props. So there's actually one prop that's just placed on the bottom, and then the other one that's coming through, and we're retargeting that for all intents and purposes onto the same similar skeleton. So a couple of more things. So at the ground level, we talked about how bones are points, and if you extract that up a level in time, you have animations or geometry caches. And then the next concept that I'm going to introduce here is motion clips, and it's essentially a motion cache, geometry cache. It's basically a motion cache all at once. So you're seeing the whole geometry cache, all of the frames at once, similar to the trail stop, if you're familiar with that. So in this motion, we're going to have an animation that I want to cycle. So basically we have this clip. First thing I want to do is use the extract locomotion to actually kill the locomotion from the hip. So here I can just say my root motion is coming from the hip, so I want to neutralize that. And then the motion clip is what actually unfolds it out into 4D time and basically makes it so it's not time dependent. So if you notice, there's a little green badge next to the extract motion that is not on the motion clip. That means it's time dependent. And we can kind of change it as well. By making it non-time dependent, it just means it's going to cook faster, and it allows you to operate on the neighboring frames, which is something that we can't do if we only have 1 frame available to you. Again, they're just regular points that you can do whatever you want for it. But in this case, we're actually running it through the motion clip cycle, and then motion clip evaluate will kind of bring us back into the single frame. So I just played that one more time. So we have the animations coming in. We use extract locomotion to kill the root motion, so we're cycling in place. And you can say which axis you want to kill. In this case, we're going to give us back the y-axis. We're converting it to a motion clip. At this point, we can do all sorts of crazy stuff, and lopping off the feed and smoothing just the feed, feeding that into a full body IK, you name it. I'm just going to feed it through a cycle, so it kind of blends. And then the evaluate will kind of get us back into a single frame at a time. And I actually didn't like the motion on the hips because it kind of floated up. So I'm going to do that. I could fix it with a rig pose and just manually kind of fudge it. But in this case, I'd just rather kill it. So now that we have this little setup, we're going to do something the next level up, which is I'm going to duplicate that. I'm going to paste a different animation. And I want to do my sausaging of upper body and lower body. So I want to take this motion and I want to do that skeleton blend that I did with the crunch character. I'm going to set up a group mask so you can see how easy it is. So I can just basically say upper body joints are going to come from the different animation, and you can see here I can just feed it to my existing chain and it will do the looping and the cycling. But in this case, it's actually looping the beginning of the animation, which is not what I want. So I'm going to use a time shift node to shift my animation forward in time by around 50 or 60 frames. So because I don't really care about that beginning where the arms goes up, I just want where it's actually up already. So you can see here I shifted that time. And now if I look at my looping animation, it has the updated arms. So again, if you're familiar with state machines, this should be very, very familiar to you. And you can see this is the beginning of a clip editor or like a nonlinear editor. So again, we need some more UI to get to that, but rest assured, we're looking into that. So the final thing I want to talk about is custom rigs. So whenever I demo this, everybody's like, oh, these are cool lines and dots. Can I actually do my NURBS art that I like to do so much? So here we have again our Eric model from Christoph Desi, and I made a custom rig just to demonstrate a very simple one, but I'll show you how it is. So here I have a name constraint looking at the pig head, and I have my IK controllers to kind of do my hand. I have FK on the arms. I can go in and pose my arms. I can go into my fingers. There are different colors. I can select multiples of them and do my finger curls. So this should start feeling more like what you'd expect out of a rigging system. But the trick here is that it is still very much procedural. So the rig is actually attaching to an animated setup. So in this case, I moved my arm and then the rig kind of builds itself there and then detaches it. So that's why we have, it's similar to the concept of ephemeral rigging. Not all the way there because the ephemeral is going to be purely on the viewport. But this is more of the kind of just-in-time rig where you can say it's a micro rig. Maybe I lopped off the pig head for just as a name constraint. Or maybe they're different rigs. So in this case, they're just the same one that I can chain them together and you can see I can override them. But the thought would be that an animator could select and be like, I want a different hand rig. I want a different upper body rig. I want to set up things a little bit differently. So here we can actually start looking at, it feels like it's an animation layer where every layer has its own rig. And then we can kind of start coming in here and seeing what's happening. So you can see we have a visibility SOP, which I actually have to go up one level and bypass another one because that's the one that's hiding it. So we can see what's happening. So here I'm setting the hands to be yellow, creating some extra bones for my controllers. Again, very similar concepts that you should be familiar with right now. And then we have this actual attached control geometry. The compute rig pose is where we're going to inject our setup, and then we can basically do an attribute copy and then finally feed it into a rig attribute to do the actual calculations. But if at any point I want to change my rig, it's very easy. So here I didn't like the pig head. I wanted a different controller, and just to show that controllers are just pieces of geometry that are essentially copy to points onto the actual controls. That's what we have. So here you can see I changed it, but I was missing controls on the spine. So that's something that my animators complained to me and they say, hey, we need that. We need a new HDA that has that setup. So I can come here to my control geometry. I can just say, okay, add another entry, and the controllers already exist, right? Because they're already just the bones. You can duplicate more and make separate ones, but in this case, I just want to kind of parent them directly. And I want to make them my large circle, and I want to make that circle a little bit larger. And there you have it. Now I have skeleton controls or spine controls that I can go in, I can animate, and my animators are free. I can make a version 2.0 of the rig. It's just an HDA. Then the next time they open their scene, it can be updated, or they can manually bump the versions. So it's up to them. So again, this is the very beginning of a full rigging system. This is admittedly the part that still has a little bit more to come, but it's possible now. And for people that are probably looking at this, they're already fearless and going into something new. If you want to go a little bit deeper into the rabbit hole, rest assured we got your back, and it does support all of the things you want it to support. So I know it's a long presentation, big overview. Main takeaway, rigging now is in SOPs. So that is a fundamental change to rigging and animation that I'm super thrilled to be able to say that we got through. We're focusing mainly on dense data processing, even though you just saw that we can do regular hand key animation, very much driven, much like a state machine. So if you're familiar with the state machine, you'll feel right at home, and is the very first of many updates. So this is the foundational level. There's lots of things that we know need to come, and we're working hard to give it to you. So finally, I want to say again, thank you. You've been